For example 4, we have to determine which of the following functions is strictly above x minus 1 squared plus 2. Well, for the first one, it uses x plus 1 squared plus 2. And when you change that, you're really just shifting left or right. And as we saw in the lesson video, that really confuses what's above or below. So that's not going to be the answer. And x minus 1 squared plus 1 is really just 1 below our original function. In fact, let me graph it. So I'll graph the original function in black, and now let's think of how to graph this. Well, this is really just the plain old x squared shifted 1 to the right and up 2. So my new origin from the beginning, my new vertex is really just the middle, 1 to the right and up 2. So this is my new vertex. And because the a is just 1, it's going to be the same narrowness or wideness as just regular y equals x squared. So that means I can go over 1 up 1, and if I go over 2, I go up 2 squared, which is 1, 2, 3, 4, and the same thing in the other direction, and it's symmetrical, so it's a lot easier to draw than by plugging in points. So we get something that looks kind of like this for our function that they gave us in the beginning. Now let's try drawing this one. That's really just the same thing, but it's shifted down 1. So now this is my new origin, and over here are my points, and I can connect the dots. So you can see that this one is in fact strictly below the original function. So that's not what we want. And now let's try the third. So this one, I'll draw now. It's really just the same thing shifted up 1. So this is my new vertex, and these are my new points. And of course, if you're drawn very well, it'll be a lot more obvious. There won't be many close calls because I'm not good at drawing points or something like that. Anyway, you can see that this is indeed strictly above our original function. So this is true. So now let's check the last one. I'll do the last one in this gold color. So the last one is like what we have originally, but it's narrower by a factor of 2. So it's like twice as narrow. And its vertex is actually going to be at this point up here. So if it's twice as narrow, that means, let's imagine it not being any narrower or wider, just having the 1. It's just going to be the same thing shifted up. It would look like this. I did it in gray because it's not really what we're looking for. In fact, when we're making it twice as narrow, we're taking all of these points and sort of doubling their height. In a manner of speaking, it's really doubling compared to this line of the vertex. That will effectively make it narrower. So originally I moved over 1 and up 1, but now I'm going to move over 1 and up 2. Before I moved over 2 and up 4, but now I'm going to move over 2 and up 8. So my points are going to end up looking something like this. And if you compare this to the black line, the black graph of the parabola, it is strictly above. Because not only is it further up, if it's further up, that's still strictly above, but it's narrower. And narrower doesn't affect anything. Now, if it was wider, something bad could happen. If it was wider, they could intersect. But that's not the case. Because it's narrower, they will never intersect. And the gold one is strictly above the black one, so that is an answer. So the last two are solutions to this problem. For number 5, we have to find an equation for this parabola. Well, to begin with, let's plot these points, or let's write down their coordinates. So this first one, it's to the left 1 and down 2 from the origin. This one over here is to the left 2, and it's on the x-axis. and this one's just the origin. Because of what we know about the vertex of a parabola, this is really just B, and that's really just C. So B is -1, and C is -2. So now all we have to do is find A. Now let's look at the case when A is 1. When A is 1, it's kind of like just plain old x squared. But of course, in this case, we want to look at x squared shifted over to the left 1 and down 2. So in that case, my vertex is in the same spot. But to go away from that, I'll go over 1 and up 1. Over 1 and sort of up 1 squared. I could go over 2 and up 2 squared, which is 4. 1, 2, 3, 4. And of course, it's symmetric, so over here, I have something similar. And this would end up looking something like that. Now that's when A is 1. We want to find what A is in this case where I drew the line in black. Well, in red, this point here is at -2, -1. And this point here is at 0, -1. So it's kind of like those points in gray, those points for the black line, except down 1. In fact, it's twice as close to my red equation, twice as close to the vertex, rather. So that means looking at my red equation, if I sort of double those y values, instead of going up 1 here, if I went up 2, it would take me over there. So I'm really trying to get twice as narrow. And because it's twice as narrow, that tells me A is equal to 2. You could also think of it as here, I went up 1 unit to get to -2, but I want to go up 2 units before I get to -2, so I'm going twice as much. So there again, you can think A is 2. This means the solution is that our function of x is equal to A times x minus b, which is -1, squared minus 2.